Okay, YouTube, in this video, what we're going to do essentially is compare and contrast two different models for a given data set. So let's say we have some given data set. Who knows what it looks like here? Maybe it looks like something like this. And one person argues that, I think that an exponential growth model models this data the best. And another person argues, no, I think a linear model models the data the best. But one thing we know about at least population growth is that it tends to be an exponential type of growth. So maybe at least at one point it looks like a linear model would fit it very well, but down the long road, like down the long run here, you can see how that's not going to fit the data very well. So here's the question we're going to confront here. It says use the models f of x equals, and we have this linear thing, y equals mx plus b here, and g of x equals a times b to the x power. So we have some y equals ax plus b. This is our linear model. And we have our y equals a times b to the x power, our exponential model here. So what we want to do is, as the world population in 1970 was 3.7 billion people, so it says which function serves as a better model for this year. And so what we have here is this. We have the world population in 1970 is 3.7 billion. And I'm just trying to look here. A better model for this year. Well, I suppose that if we want to call it this, we could say that 1970, I'm going to go ahead and assume that we mean that the time equaling 0 represents 1970 during the first, say year in this model. So what we're going to end up with here is our two models, f of, and we're going to say f of 0, and we're going to get g of 0. And what we're going to do is we're going to compare our two results here. And so with f of 0, we get 0.074 times 0 plus 2.294, which essentially, when we simplify that, gives us 2.294. And I'm going to label this in billions. And so we'd say initially, this gives us 2.294 billion people if you look at this in the model sense. Now, if we plug 0 into the exponential model, we get 2.577, and this is times 1.017, and this is all to the 0 power. So essentially what we get is 2.577. I'm also going to label this in billions here, and this is g of 0. Now, what we ended up with in either instance here was what our model predicted we got in the first year that we look at this. So according to the data, there were 3.7 billion here. We would say that which model serves as a better and more accurate model for this year. And so assuming that that's the first year there, time equals 0, then I would suppose that this is the better model because it is closest to 3.7 billion. Now, letter B here, it says by one projection, world population is expected to reach 9.3 billion by 2050. Which function serves as a better projection for this model? So by 2050, we would say that that is how many years after 1970. And so I would say, well, you have to add on 30 to get to 2000 plus another 50, so we'd say 80. And so plugging this into the model here, this would be the year 2050. What we'll do is we'll find f of 80, and we'll find g of 80. And this is, we'll make a little snowman there. There we go. So plugging this in, we get 0.074 times 80 plus 2.294 over here. And so getting out our calculators, let's just go ahead and evaluate this here. According to our linear model, 0.074 times, in parentheses, we'll put our 80 here, and then we'll say plus 2.294. What we end up with here, and I'll go clean this up. We don't need two decimal places here. Here we go, 8.214. So we would get 8.214 billion people in the year 2050 according to that linear growth model. When we look at exponential growth model, then we would have to say, well, going back then, we had 2.577, and this would be times 1.017 to the 80th power. And so now typing this in with our exponential model, 2.577 times our base b, 1.017, and this is to the power of 80. Then what we end up with then is 209.66 billion. So we say g of 80 is approximately 209.66 billion. And so what I would say that if in 1970, we have approximately 3.7 billion. We say, well, which one's the better model here? 80 years down the road, are we going to have 8.2 14 billion 80 years down the road, or 209 billion, I'd say that it makes more reasonable sense that with people breeding, you're going to have with the exponential growth model here. So we say that would be the better choice. Cheers.